Welcome back, students. Today we are going to get into graphing quadratic functions. So quadratic functions, you might see them written with the fancy function notation where you see a letter and then inside parentheses it's stating that independent variable, that domain, that x value. Or they could be written as a quadratic equation where you might see y is equal to. Or another option is you might see it as 0 equals. But the main thing is what it's going to be equal to. So something x squared, and then you might have the linear term, which might be represented by plus bx, and then a constant. So the one part of the quadratic function that it has to have is the x squared term, something squared. So if you were to graph these by hand, you're going to realize that if you take 0 squared, you're only going to get 0. But if you were to take 1 squared, you get 1. But if you also take -1 and you square it, you get +1. So what happens is, even though you're going to input positive and negative values, those negative values that you input, if you plug them just into the most basic function, that y equals x squared, they actually become positive. And so you get this nice symmetric graph. This is called a parabola. Right? It's a U-shaped curve. So make sure that when you're making your graphs, you make sure that it's a U-shaped curve and it doesn't get confused with a V, which will be a different type of a function. So a quadratic has to have that x squared term, and then whatever else it has, it's still going to be a parabola, but it's going to cause some shifts and it's going to cause some changes to what we have for our graph. So our graph can either open up or down. Our parabola can either open up or down. If it's a positive, it will open up. And if we have a negative in front of that x squared, it will open down. And if it opens up, you can see that as you trace the graph, you have a lowest point. That lowest point is called your minimum value. Or if the graph opens up, and it becomes a maximum value. Not only is it the lowest point or the highest point on the parabola, but it's also where your symmetry occurs. That is called your vertex. So the vertex, okay, it's going to be either the highest or the lowest point on the graph, aka the maximum or the minimum point on the graph, depending on if that graph opens up or if it opens down. The notes are attached on Google Classroom, so I'll let you read through all of this. This is telling you step by step what you're going to do as you graph your quadratic functions. I'm not going to read this to you. You can read it on your own. Instead, what I'm going to do is I'm going to walk you through these steps as we do some of our own examples. The one thing I do want to highlight from all of this is it says a quadratic equation. If we're using graphing in order to solve, we need to know how many solutions we're going to have for a quadratic. So because a quadratic is guaranteed to have this x squared term, what this means is we're going to have 2 solutions. Now, what type of solutions are we going to have? Well, we might have 0 real solutions. What that would look like would be something like this on our graph. 0 real solutions would be a graph like this. The reason why this would be 0 real solutions, well, another word for solutions, all of these are synonyms that you need to link together. X-intercepts, roots, zeros, solutions. So when it comes to a graph, to find your solutions, you look for the x-intercepts. So ask yourself, if you were to trace this graph, where does it cross the x-axis? It doesn't. So that means that there are 0 real solutions. Now, right here, I said that there are going to be 2 solutions. It's just those are going to be non-real, which means they're going to have that imaginary number I in them. We'll have to use a different method to solve in order to get those non-real solutions. Today, when we're graphing, all we can state is if there are 0, 1, or 2 real solutions. So here's an example where we would have 2 real solutions. Here we have our parabola, and looking for our solutions, we're looking to see where does the graph cross the x-axis, those x-intercepts. So in this case, it crosses the x-axis in 2 places, so these would be my 2 x-intercepts. My 2 solutions would be -2 and +2. They are where they cause the function to be equal to 0. The last possibility is when you have your graph and you have the vertex, the maximum or minimum point, that is on the x-axis. That means that it's on the x-axis. That is going to be what's called a double root. We will figure that out. We'll see that more later when we solve algebraically for our solutions. It's going to be a root that when we solve algebraically, we get the same answer twice. It's going to be a double root. That occurs anytime that you have your vertex on the x-axis. Okay, so that can also look something like this. Okay, here we have our vertex that's on the x-axis. That was one real root. That is called a double root. All right, so let's get into graphing these and using our graphs, analyzing them, talking about their different properties, as well as using them to solve. So here I am given an equation, x parentheses 6 minus x equals 10. First thing that we should do is put this into standard form. Solve this for either y or for 0 or for that f of x. Get that by itself on one side. So I need to do a little bit of manipulation here. First thing I would do is distribute the x. This would give me 6x minus x squared is equal to positive 10. Rearrange this a little bit, get all the terms on one side. So this is going to give me negative x squared plus 6x. Move the 10 to the other side, which will be a minus 10, and then that would be equal to, since we moved it over, this would be equal to 0. I could have it equal to y, I could have it equal to f of x. It really doesn't matter what this notation is over here. What matters is making sure my signs are correct and I have this in the correct order. The number in front of x squared is called the leading coefficient. The letter that we denote with it is your a, and so this leading coefficient would be negative 1. That's going to tell me that this graph opens down. The b is what's in front of the x, and that's going to be a positive 6. And then the c, the constant, is negative 10. So you can algebraically find your vertex, which is usually denoted by the letters h and k to make the ordered pair h comma k. You use the formula h is equal to negative b or opposite b over 2 times a. So when I plug these values into my formula, I get negative 6. So that was opposite 6, so negative 6 over 2 times a. So that'll be 2 times negative 1. So that's going to give me negative 6 over, that's an equal sign. Negative 6 over negative 2, and negative 6 divided by negative 2 would give me positive 3. All right, that is the x-coordinate of my vertex. My vertex is going to be my center of my graph. So when I go to make my table of values, I am going to put the 3 as my center. I'm going to put my vertex as the center of my parabola. To figure out what the k value is, I know what my x value is, so I plug it in and I get it whatever my k is. So this will be negative. I replace my x with 3. I'll square that. Plus 6 times 3 minus 10. 3 squared is 9, but there's a negative out in front that's not being squared. So that's going to be negative 9 plus 6 times 3 is 18 minus 10. So I'm just using order of operations. Negative 9 plus 18 is going to give me positive 9. 9 minus 10, that's going to give me negative 1. All right, now I just did all of that algebraically, which is a fair amount of work. You should be capable of doing that. But we also have technology now that exists that makes it very easy for us to find our vertex and actually to do all of this. So if you want to use a graphing calculator, I will teach you how to use a Casio or a Texas Instrument. Desmos has become the best graphing calculator tool that we have. The only downfall with it is upper level math classes, as well as taking the SAT and the ACT. They don't allow it. So it is helpful to be able to use a handheld graphing calculator. But here's how Desmos works. We're going to type in what the equation was, which was negative x squared, and then plus 6x minus 10. Plus 6x minus 10. You can type in that equals if you want to, equals y. I think if you put equals f of x, nope, it didn't like that one. equals 0. No. Equals y, equals y, or just not putting that equal sign at all is what Desmos likes as far as the notation goes. So here's my parabola. I said as I was identifying my A, that because the A is negative, the graph opens down. And if I click on my parabola, I find my highest point, aka my vertex, and that is at 3, -1. So then what you're going to do is up here is in the gear, it says edit list. You're going to click on that. You're going to convert to a table, and you want to make the vertex be the center of your table. So then you're going to count up and you're going to count down. So 3, 4, 5, 3, 4, 5, then 5, 4, 3, 2, 1. These are going to be the values that we want to include in our table because we want to get a few values to the left of our vertex and a few values to the right of our vertex, because the vertex is where the symmetry occurs. So filling in our table, again, I counted up, so 3, 4, 5. I guess I can do one more, 6, and then 6, 5, 4, 3, and then 2, 1, and 0. So use Desmos or a graphing calculator to get what these values are. So this is -5. This one was -2. This one's -2. This is -5. And then for my 0, that's at -10. If I do 6, that's also at -10. So hopefully you're seeing that those values repeated, because our vertex is where the symmetry occurs. And so since these points are the same distance away from that axis of symmetry, that means that these y values repeat. Okay, when we were 3 away from our vertex, okay, both of these y values are at the same height. When we're 2 away from the vertex, both of these y values are at -5, and so on. Okay, that's because of the symmetry. Okay, so the axis of symmetry is going to be x equals the x coordinate of the vertex. Okay, a lot of alliteration there, a lot of working with x. Axis of symmetry for the vertex, and it's the x coordinate. So that's going to be the vertical line, x equals 3. It's always going to be x equals, and then you just use the x coordinate of your vertex. While we're at it, identifying a maximum or minimum. Looking back to our graph opens down, which means our vertex is the highest point on our graph. So that means that it's a maximum, and the maximum value is -1. All right, let's go ahead and get our graph on our paper, which just is going to be a matter of plotting points. So I'm going to pause the video, get my graph, and then I'll just talk about it. All right, so something that I should note as I was making my x-axis and my y-axis, which I'll go ahead and label those, my x and my y-axis. The reason why I have my x-axis so high is because I looked over here to see what I was going to be graphing. And since I noticed I was going to go all the way to -10, I made sure that -10 would be included on my graph. So don't just automatically put these in the center of your graphs. Look ahead. What x values do you have? What y values do you have? Make sure that those will be accounted for. If you need to, you'll have to change the scale, or hopefully you can just change where you place the x-axis and the y-axis, and then you'll be able to plot those points. So now I'm going to go through and I'm going to plot all of these ordered pairs. So here are all of my ordered pairs that have been plotted. Notice that they make a U-shaped curve. My last thing that I need to do is try to connect these the best that I can. It will just take practice, and forgive me, that's not very good. I'll try again. It's pretty difficult to get it, especially on your first try. So just go the best that you can to get through those points. The main thing is make sure it's rounded when you're going through at the vertex, because again, if you make it look like a V, that is going to be more like an absolute value graph, which we do not have. All right, so this is fair. This is decent. I'd like to have done better, which I could have done if I wasn't on the computer, but you get the point. The next thing that I'm going to do is I'm going to go through and I am going to then analyze this graph. I'm going to look at the domain, the range, the y-intercept, the x-intercepts, the solutions. All right, I'm going to pause it, charge my Chromebook, and I'll be right back. All right, so the domain is your x's. Domain, how far to the left, how far to the right can this go? So if I were to trace this graph, even though it's going down, it can also keep going to the left. If I get onto Desmos and I type in the smallest number I can think of, so negative, I'm just going to keep going as much as I can. Okay, notice that it's telling me a y value. It's telling me that it exists. All right, so it's not something that I'd want to graph by any means. That would be really far below that x-axis. But because it's right here, because it's not telling me undefined, it means that it exists. So what that means in terms of the domain is it goes on forever to the left, which the smallest number is not actually a number, it's a concept. It's negative infinity. Remember that whenever you are using infinity, you use parentheses when you're writing your domain and range in this notation. So then what's the farthest to the right that we can go? Well, same thing. If I were to change that to a plus, do I get values? Yes, I do. I could go on forever. So this is going to go to positive infinity, again, parentheses. So this means all real numbers. Okay, I have it in interval notation, so that's why I have it written like this using symbols. Domain, whenever you're working with quadratics, will always be all real numbers, so negative infinity to positive infinity using parentheses around those. The range will either be negative infinity to something or something to positive infinity, depending on if your graph opens up or if it opens down. So because this graph opens down, notice I could go down forever. The arrows are pointing down. So that means that my range goes from negative infinity, but then it reaches a maximum point. So this is the highest value that I have. What is the y value? Remember that your domain are your x's, your range is your y. So looking at my y values, what's the smallest, or not the smallest at all? What is the maximum? What is the largest y value that we have? And that is -1. It reaches to -1. It's including that point, so we use a bracket around that. The next one, the y-intercept, is really easy to find. You can trace it on your calculator. As far as on Desmos goes, to be a y-intercept, it means when x is 0. So this is at 0, -10. Or on your graph, if you scroll down enough to see where it crosses, you can click on your parabola and it automatically comes up with that point because it's such an important point that we need to include it. So 0, -10. I guess we could have also found it up here in our table. X-intercepts, where does the graph cross the x-axis? And actually, this graph does not cross the x-axis. So that means that there are no x-intercepts. So I'm going to put none. Solutions then, how many times, where does it cross the x-axis? It doesn't. So it's no, I can't just put no solutions. It's going to be no real solutions. So that means in a few days, when we learn about solving, we would have to solve this algebraically to figure out what those non-real results are. And we would actually have solutions. It's just we can't solve this one by graphing. Let's take a look at one more example. So first thing, again, what you need to do is get all of the terms on one side. And so in this case, I'm going to move. My last one was negative. I'll make this one positive. So I'm going to keep the 3x squared where it is. I'm going to move the 11x over, so I'll have minus 11x, and then I'll move the 8 over. It does not matter which one you do at all. So I'm going to click out of this, and I'm going to type in what my new equation is, which is 3x squared minus 11x, and then minus 8. All right, so this graph, I might want to zoom out just a little bit to be able to see it all. But this graph, because the number in front of x squared was a positive 3, it means that the graph opens up. The number in front of x, that's your b, that's negative 11. And then the constant is negative 8. If you wanted to show work for your vertex, I'm actually not going to make you show work since your calculators and since Desmos can do this for you. Remember what you would use if you were doing this algebraically. We would take the formula h equals negative b over 2a and plug these values into that. So you would have positive 11, because you change the sign for your b, and then take 2 times your a term. So this would give us 11 over 6. So another reason why we should go ahead and just use the graphing calculator, because working with fractions, we don't like to do that. All right, so we get 1.833 repeating. We just figured out that that is the fraction of 11 over 3. Or sorry, not 11 over 3, 11 over 6. This is our vertex. All right, so then what you do is you go to the list, convert this to a table. We want the vertex to be the center. So we're going to have 11 over 6 as our center. Okay, and double check, what is that y value? Yes, it's the negative. That's our vertex. So if you wanted to, you could type that in as whatever that decimal equivalent was, which was 1.833. Or if you want to type in the fraction, you can type in the fraction. Either way is fine. If you're going to be using decimals and we have decimals, I'd say go ahead and round to 3 decimal places. So this is going to be negative 18.083. And I already forgot what that is. So negative 18.083. All right, so then we need to get some points to the right and to the left of this graph. So this 11 divided by 6 is the same thing as 1.8. If you think on a number line, 1.8, what numbers does that fall in between? Well, it falls in between 2 and 1. So we're going to count. So 1, 2, 3, 4, and then 4, 3, 2, 1, 0, negative 1. These should be the values that we figure out what their y coordinates are and then graph them. So then come over here and type those into the table. So at 0, we're at negative 8. And type in your negative 1. And I'm going to pause the video and finish this. All right, so I used Desmos or in a graphing calculator. I get a table as well. And so all I did was I wrote down what my ordered pairs are going to be that I'm going to graph. Notice that here, our vertex is not directly in between 1 and 2. It's not halfway in between 1 and 2, which means that we don't see the symmetry like we did on the last graph, because these points, negative 1 and 4, aren't the same distance away from 11 over 6 and so on. There is symmetry, it's just we don't see it with the table, with those values that we've put it into our table. Something to note is looking at our graph opens up, which means that our vertex is the lowest point. So notice that these y values, the smallest y value that we have is here at our vertex, which is a really good sign that we have our table numbers recorded correctly. So now what I'm going to need to do is I'm going to graph this. So my x's, I go from negative 1 to 4. That's not really a big deal. That means that I can put my y-axis somewhere towards the center of this graph that has been provided. But my y values, I need to go just past negative 18. So I'm going to count and see how many values that I have. So negative 18, 17, 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4. No, I ran out of room. Okay, so that means I don't have enough to just go by ones. I'm going to need to change what my scale is on my axis, on my y-axis. So negative 18, all of these are going to be divisible by 2 basically, so I'm going to go by 2's. So that means that I'm going to make this bottom one be negative 20, negative 18, negative 16, 14, and then 12, 10, 8, 6, 4, 2. That means that right here is where I'm going to draw in the x-axis. So you'll need to get comfortable with doing the same thing, which is planning ahead before you start plotting your points. So if you can just move where the axes are located, do that. That's the easiest. But if you need to, you're going to need to change the scale. Now, I changed the scale, but right now, if somebody else was reading this graph, they wouldn't know that I changed the scale until on the y-axis, I label that this is going by 2's. If I wanted to label all of it, 4, 6, 8, 10, negative 2, negative 4, and so I could, but that's not necessary. All you have to do is label 1, and then the scale is supposed to remain consistent, so that means that I have enough already here for the reader. So then I would go through and I would plot these points. So at negative 1, I'm at positive 6. So 2, 4, here's positive 6. And then at 0, I'm down at -8. So this is -2, 4, 6. This is -8. At 1, I'm at -16. So that means this is -10, 12, 14. This one's -16. At 2, I'm at -18. At 3, I'm at -14. And at 4, I'm at -4. All right, my last point is at 11 over 6, which was 1.83 approximately. So that's my vertex. So 1, 2, 1.83 would be approximately right in here. And then it goes just below the 18. So it's going to be right in here. Really hard to tell. All right, and then you're going to do the very best that you can with connecting these points. The only other 2 points that I would suggest that you plot, we haven't recorded them yet in our list of values, but we will. And that's going to be, whoops, I actually think that I need to go back. Can I go back all the way? Convert this back. Maybe I can just type it in again. Done. No. All right. I need to retype in my equation. That's good to know. So it's 3x squared. I do not believe that you can go from a table back to just this. All right, the reason why I wanted to go back to this is because I wanted to be able to click on my graph and then get my x-intercepts. All right, so these x-intercepts, we have one at -0.622. So -0.622. We didn't change this, so it's going to be just slightly more than halfway. And then 4.288. So 1, 2, 3, 4.288 is going to be somewhere right in here. So those would be 2 points that are important points to be able to have in order to be able to make the best kind of parabola that you can. Again, this is just going to take practice to try to connect them to make that nice U-shaped curve. All right, now we go through and we analyze. Okay, so this graph, once again, it's a parabola. Domain of any parabola is all real numbers. It can go from left to right as far as possible. However, the range is going to be restricted. In this case, it goes up forever. So we always go low to high. So it goes up forever. So we know it goes up to positive infinity. But what's this lowest point? Well, it's your y value of your vertex, which is -18.083. And it's included, so we're going to put a bracket around that. The y-intercept either can be found on Desmos by clicking on it, or here it's in our table. When x is 0, we have -8. We have a graph that opens up, which means we have a lowest value for our vertex, and the minimum value is -18.083 approximately. The axis of symmetry occurs at x equals 11 over 6. Again, that's the vertical line that goes through, okay, right here. If we were to fold this, okay, it's the vertical line that goes through your vertex. All right, and then last but not least, the x-intercepts, which I already have over here. Just click on the graph to get those. My x-intercepts are written as ordered pairs. That's -0.622, comma 0, and comma, it was 4.288, I believe, comma 0. And then what we'll do is rewrite this as our solution. So we're going to write this in set notation, which means we're going to use braces around this. We write our smallest value and then our larger value. So this will be -0.622, comma, positive 4.288, and then your right brace to close. All right, so that is graphing quadratics and then being able to analyze that graph to be able to state all of these interesting facts about it. Next class, we're going to basically be doing the same thing, but we're going to be using it to model situations. So we'll make it a little bit harder because we're going to actually have a scenario behind these, and those solutions and all of these values will actually represent something. So for now, work on getting these basics down. Because we get to use Desmos, because you get to use graphing calculators, you should be thankful, because years ago, this was not at our disposal, and you used to have to do all of this by hand. So it still is a little bit of work, but really not too much work. It's just a matter of copying things down and knowing where to look. So I hope that helps. Graphing quadratics.